In this video, we're going to talk about the basics of organic reactions. So when we think of a reaction, if you put two things together and they start to do something, generally we think of that as a reaction in chemistry. So if you mix baking soda and vinegar and you get a foamy, bubbly mess, that is a reaction. The sodium bicarbonate in the baking soda and the acetic acid in the vinegar begin to react and release carbon dioxide. Now that's more of an inorganic reaction. But it's the same general idea. Certain molecules, if put together, will just start to interact with each other. Depending on what molecules you'll mix, how they interact will be wildly different. And so for each type of functional group, there are some fairly common reactions that occur. And while we'll have videos for each of those functional groups, let's talk about how we represent them. How are we tracking what is occurring? A common reaction would be burning methane. CH4 plus O2 goes to CO2 plus water. What we observe in this is that the atoms have reorganized. This is what really makes it a reaction. You can get things to interact. If you dissolve salt in water, the solid disappears. That kind of looks like a reaction, but you really haven't changed all that much. You dissolve the salt, which is a little alteration in its structure. But the water hasn't altered. The water is exactly as it was before. So you wouldn't consider dissolving salt a reaction. It's a state change. A reaction really involves atoms reorganizing. We had a carbon with 4 hydrogens. We had oxygen double bonded to oxygen. We ended up with carbon double bonded to oxygen. And we ended up with oxygen single bonded to hydrogens. All my CH bonds have vanished. My oxygen used to have double bonds. It still does, but now it also has some single bonds to hydrogens. And the double bonds it does have is to a different atom. We have reorganized what atoms are paired together and in what ways they are paired. From a bunch of single carbon bonds to atoms to a bunch of carbon double bonds to atoms. This is a reorganization, and this is a reaction. They will also follow the same general setup. If I've got one molecule, molecule A, I may or may not have a second molecule. Just depends on the reaction. Sometimes your first molecule falls apart, and that's a reaction, and sometimes it combines with something. You'll have an arrow. This is telling you the things on the left of the arrow have reacted together, and you'll have things on the right of the arrow. One, maybe more. Generally, you don't have more than 2 reactants, but you could have possibly many products. Or just one, depends on what reaction is occurring. Additionally, you have space above and below our arrow. This tends to be reserved for reaction information. What I mean by that is things like, I need heat. You might see a triangle. This represents heat. If you have to boil the reaction, this is where you would indicate that. You might even have a temperature. You might say 180 degrees. You could additionally have things like H plus or H2SO4. These are both acid. These are a catalyst. They are used in a great many organic reactions. Ends up, acid interacts really well with oxygens and nitrogens, and since most organic functional groups involve oxygens or nitrogens, this means they're really good at destabilizing and catalyzing reactions with most organic molecules. And so sulfuric acid, or generic H+, is also often written above or below the arrow to indicate a catalyst has been added. Other types of info can sometimes occur here as well. If you add or lose water, sometimes it won't show up as a separate molecule. So you could put water as a reactant, but sometimes you'll just see plus H2O or minus H2O. For reactions where, yeah, you're losing water, but they just want it to be real quick. We don't care about the fact that there's water. We're focusing on the other parts. Sometimes they put it above and below instead. It's simply because it's so common, and there's usually so many other things occurring that water gets less priority than specialized molecules would. And this is the general setup for shaping a reaction. An example that we'll see more of when we get into the functional groups might be an ester. An ester plus water will break apart and form a carboxylic acid and an alcohol. And so you could draw this reaction as the ester molecule, the thing it's reacting with, water, and the two products that we make. You could also have it with an arrow H plus H2O. And realistically, we would have had some acid catalyst up in that original one. And so these are two ways to write what is effectively the same reaction, breaking an ester apart into a carboxylic acid and an alcohol. We can see our first molecule, our second molecule, our arrow, and then our two products. Additionally, if you don't want to mention the water, you can write it with only one starting material, leading to two products. You just mention the water with the arrow. These are functionally identical. It's just whether you cared about the water all that much or whether it was a footnote in the process. This is the general layout on how an organic reaction is set up, so you can see the starting materials, the products, and any information about how to run the reaction.